Hello, let us see how to solve this particular question. So, in this, the question is basically sketch the V naught for each network of below circuits for the input shown. So, this is the input here, okay, and basically there are two circuits provided, 1 and circuit 2, and we have to get the output here for each of these circuits for the given input. So that is the requirement. Okay, now in this scenario, so these basically are called clamping circuits. Okay, so any circuit which employs diode and have an equivalent output voltage here can be called a clamping diodes because they clamp the output of the circuit to a particular voltage. And then to analyze these circuits, right, such kind of circuits, the first point that we have to start with is not just by taking whatever the first t is equal to. If we consider this as t is equal to 0, okay, the initial condition, we should not just straight away by taking this condition. That would create mm, uh, confusion with respect analysis because there is a pulse that is provided and there is a capacitor that is involved. The charging and discharging cycles of this capacitor are very important. So first we should start with a scenario where diode gets forward biased. So diode gets, if we take the first circuit, okay, this is the first circuit, right? So now if we take the circuit, okay, so this is V naught and this is R and this is C capacitor. Now for this diode to get forward biased, this basically E is ground, right? So V is equal to 0. Anything, this node, V naught node, any V naught which is greater than 0 volts, okay, we'll reverse bias this, and any V naught which is less than 0 volts will forward bias this diode. That means we should give a negative voltage here. So to give a negative voltage, that means we have to first give minus 20 here. In that case, this diode will be forward biased. So now when this is forward biased, this is grounded, right? So V naught will always be 0 in this case because the diode will be forward biased. So as it is grounded directly, the current passes through this capacitor and this capacitor charges. Okay, so one thing which we have to remember here is basically the current will not be in this direction because it's a negative voltage, right? So the capacitor charge will be this way, the current will be in reverse direction. Okay, now in this scenario, if we see, if we the basically the output voltage is 0 volts, that is very clear. So for a given 20 volts, minus 20 volts, the output is 0. Now let us take the scenario of minus plus 20 volts. Okay, so we have taken minus 20 volts. Now take the case of plus 20 volts. So plus 20 volts, this diode will be reverse bias. That means this will be open, and then the capacitor might have charged to already 20 volts previously, right? So if we do a Kirchhoff's law of this entire section, okay, starting from here, minus 20, okay, and then again minus VC, which is capacitor voltage, is minus 20, plus V naught or VR if we put it, is equal to 0. This is the KVL, right? Which is equal to 0, not 0 volts. So in this case, V naught becomes 20 plus 20, which is 40 volts. Okay, so in this circuit, the output will fluctuate between 0 and 40 volts as per this waveform. Now if you give 20 volts, the output will be 40 volts, and then when you give 0 minus 20, it will be 0. So for this, the from when you start from t is equal to 0, this is how the waveform will be. Now let us go to this scenario. Okay, so same scenario. This is minus. We have to start with on condition, right? So on condition means here actually we have minus 5 volts instead of 0 volts. Okay, any voltage, any voltage here greater than, okay, greater than minus 5 will have this diode forward biased. Any voltage less than minus 5 volts will have this diode as reverse biased, because sorry, forward biased, because the voltage on this side is greater than the voltage on the cathode side. That's where the diode is forward biased. It's an ideal diode, right? So now for this V to be minus less than 5 volts, very clear, right? We have to give 20 volts. Okay, when you give 20 volts, so this, as this diode is forward biased condition, minus 5 volts is in parallel with R. Okay, right? Very clear, right? Minus 5 volts is in parallel with R. That means V out is straight away minus 5 volts. So when we give minus 20 volts, when this diode is forward biased, output is minus 5 volts. And then when you give 20 volts, positive 20 volts. Okay, so this capacitor would have already got charged to plus 20 volts, and this actually diode will be reverse biased in that state. Now, what happens is we have to do the Kirchhoff's voltage law again, where one difference which you see with respect to this scenario is there is a negation of minus 5 volts. So until this reaches 5 volts, this diode will not be off. So that means we have to negate 5 volts from this, which where the output becomes like if you take a KVL, minus 20 volts. Okay, and then again this will be minus 20 volts plus V naught is equal to 0, which means V naught is equal to 40 volts. But what happens is this particular diode will be off, it will be in on state until minus 5 volts, right? So there will be a negation of 5 volts, so that means that the V naught will be 35 volts. So in this scenario, the output voltage will vary between minus 5 volts to 35 volts. That is how we have to analyze the circuit. So one rule of thumb, start with the case where diode gets forward biased, and then go to the condition where diode gets reverse biased. And you need to know when the diode gets reverse biased, when the diode gets forward biased, and also KVL is very much required. So with these scenarios, we must be able to analyze this circuit. So typical analysis, but with very simple rule of thumbs, we can do this analysis. Thank you. Please post if you have any questions. Please let us know your inputs on this video. Thank you.